Hello students, today we'll discuss IB Physics HL Paper 1, May 2021, Time Zone 1. In this paper you cannot use calculator. My name is Nariman Meryem. I am located in Baku and here you can see my mobile and email. To prepare for exam you can use the following sources: main huge textbook from Oxford, short textbook for preparation by Sokas, and to revise and understand topic better, Tim Kirk study guide. When you are doing past papers, you should already have physics data booklet 2016 copy, and it is desirable to have physics guide, physics data booklet and physics guide. Let's start. So this paper was given to students on Monday 3rd May 2021. Question 1. Two sets of data shown below with circles and squares are obtained in two experiments. The size of arrow bars is the same for all points. What is correct about absolute uncertainty and fractional uncertainty of the y-intercept of the two lines of best fit? So we have two experiments. In one, points are given as circles, in another squares. So two experiments. Y-intercept for these two experiments, let's just a moment. So y-intercepts are these points. So here for circles y-intercept is 1, for circles it is 3, uncertainty is half, so each big unit is 1 or vertical, and uncertainty is plus minus half. So we can calculate. So fractional uncertainty, absolute uncertainty is the same, as we can see, they tell us, but fractional uncertainty is uncertainty divided by value. Here value is y-intercept, so for squares we divide by 1, for circles we divide by 3, and we can see that fractional uncertainty for squares is larger, so we choose choice D. Question 2. A large stone is dropped from a tall building. What is correct about the speed of the stone after 1 second? So tall building, large stone means that air resistance is not negligible. So speed is increasing during the fall as resultant force equals weight minus air resistance. But as air resistance increases, as stone speeds up, hence resultant force and acceleration decreases. Acceleration is rate of speed of change. So rate of change decreases, so speed increases at decreasing rate. Choice D. The graph, question 3. The graph shows the position of an object, how the position of an object varies with time in an interval from 0 to 3 seconds. At which point does the instantaneous speed of the object equal its average speed over the interval from 0 to 3? From 0 to 3, average speed. To find average speed we need distance. Distance is 3.5 minus 1 traveled during 3 seconds. So we divide distance by time, we get 117 meters per second. To find instantaneous speed at A, B, C, and D, we can draw a tangent line, and the tangent line should be equal to instantaneous speed, and at the same time we need tangent gradient should be equal to average speed, so about 1.2. So I have sketched here gradient 1. I can see that gradient at B is much less, gradient at D is much more, so the best candidate is C, so choice C. Question 4. A car takes 20 minutes to climb a hill at constant speed. The mass of the car is 12,000 kg, and the car gains gravitational potential energy at the rate of 6 kilowatt. Take the acceleration of gravity. What is the height of the hill? So we have given time, we convert it into seconds. Speed is constant, mass is given, constant speed, then kinetic energy doesn't change. Not in booklet, power equals energy over time. We can calculate energy change during this rise. So power multiplied by time give us so many joules. On the other hand, the energy change is mgh, potential energy change. So we rewrite this formula for height. Energy change we take from power. We divide, we put mg, and we get 600 meters, so we get choice C. A mass is released from the top of a smooth ramp of height h. After leaving the ramp, the mass slides on the roof horizontal surface. Rough. The mass comes to rest in a distance d. What is the coefficient of dynamic friction between the mass and horizontal surface? During sliding the ramp, potential energy turns into kinetic energy. It is smooth, so no friction. So change of kinetic energy, gain of kinetic energy is mgh. Horizontal surface, this potential energy turns into heat because friction is working, and work equals force times distance. Dynamic friction is given by this formula from booklet. Reaction is mg here because it is horizontal surface. By rewriting formula for mu dynamic, we are getting a choice D. Choice D. Choice D. Question 6. The masses x and y rest on a smooth horizontal surface and are connected by a massless spring. The mass of x is 3 kg, mass of y is 6 kg. The masses are pushed toward each other until the elastic potential energy stored in the spring is 1 joule. The masses are released. What is the maximum speed reached by mass y? Here, when we say masses were pushed toward each other, we mean that they are moved toward each other and then released. Maximum speeds are reached when x and y moves apart and spring is unstretched, so no strain energy. As later springs slow down the masses, Conservation of momentum tells us that the momentum are equal by absolute value but opposite of mass x and y. It means that x has 2 times more speed than y because it has 2 times less mass. Conservation of energy tells us that elastic potential energy changes into kinetic energy of x and y. So elastic potential energy is 1 joule. On the right we have kinetic energy of 2 masses. We substitute x for y and we get formula for y, and it is 0.33, so choice B. Choice B. Question 7. A force acts on an object of mass for 40 kilograms. The graph shows how the acceleration of an object varies with its displacement d. What is the work done by the force on the object? First, we will find total area under the graph. So we have under the graph we have rectangle and trapezium. So we use formula for rectangle and trapezium, and we find that the total area under the graph is 50. Now imagine that we multiply A by mass, and we're getting force distance graph, and area. We know that area under force distance graph is work done. So we simply multiply our result for acceleration by mass to get how much will be area under force time force distance graph. So it is 2000, choice B. Question 8. Which aspect of thermal physics is best explained by a molecular kinetics model? We get equation of state, choice A, from kinetic theory, molecular kinetic theory, so we choose choice A. Question 9. When 40 kilojoules of energy is transferred to a quantity of a liquid substance, its temperature increases by 20 Kelvin. When 600 kilojoules of energy is transferred to the same quantity of liquid at its boiling point, it evaporates completely at constant temperature. What is the ratio of specific latent heat of vaporization by specific heat capacity of object? So we use booklet formulas, two formulas, one for specific heat capacity, another for specific latent heat of vaporization. We substitute values that are given, and then we divide C by L, and we find that it is 300 Kelvin, so choice D. Very simple question. Question 10. Two ideal gases X and Y are the same temperature. The mass of particle of gas X is larger than the mass of particle of gas Y. Which is correct about the average kinetic energy and average speed of the particles in the gases X and Y? Subtopic 3.2 booklet, modeling gas. So average kinetic energy of molecule equals 3/2 of R over N Avogadro, and temperature. So constants and temperature. So same temperature, same average kinetic energy of atoms. As atoms of particle of Y is smaller, the speed is larger to have the same kinetic energy. So we choose choice B, average kinetic energy is the same, but average speed larger for Y. Question 11. An object performs simple harmonic motion. The graph shows how the velocity v of the object varies with time. So we have graph. The displacement of object is x, acceleration is a. What is the variation of x with t and a with t? So we have x graph and a graph. And initially we have information about v graph. So I remind you that displacement, velocity, and acceleration are linked by differentiations. So to get v, we differentiate x, to get a, we differentiate v, and by integration in opposite direction. To get v, we integrate a, to get x, we integrate v. So here we have v. So v is cosine function. So to get x, we should integrate, we get sine function. To get a, we differentiate, we get minus sine function, because derivative of cosine is minus sine. And so we have sine function for x and minus sine function for acceleration. So we choose a. So here we have sine for x and minus sine for a. Choice A. A sound wave have a frequency of 1 kilohertz and wavelength 0.33. What is the distance traveled by the wave in 2 milliseconds and the nature of the wave? So SI unit, frequency we change into hertz, milliseconds into seconds. Formula booklet 4.2 traveling waves, wave equation, speed equals frequency by wavelength. So speed is 330 meters per second. Distance traveled will be speed by time. We get 0.66, and sound wave is always longitudinal wave, so choice C, distance traveled and longitudinal wave. Question 13. Monochromatic light of wavelength lambda is incident on double slits. The resulting interference pattern is observed on the screen at a distance y from the slits. The distance between consecutive fringes in the pattern is 55 mm when the slit separation is A. So lambda, y, and A are doubled. What is the new distance between consecutive fringes? So subtopic give us distance between fringes equals lambda d, small d. So here we change distance to screen y to d. A we substitute for separation. And now we start. So if we double all three parameters, we get 2. So we double lambda, we get double d, capital D, and we double 2. So factor 2 is left. So actually we double the fringe distance between fringes. So originally it was 55, now it becomes 110, so it is choice B. Question 14. It is a bit difficult questions always. So we vibrate metal rod and we produce sound. So different object and different wave. A metal rod of length 45 centimeters is clamped at its midpoint. The speed of sound in metal rod is so much. The speed of sound in air is so much. The metal rod vibrates at its first harmonic. What is the wavelength in air of the sound wave produced by the metal rod? So first of all, we draw how it vibrates in first harmonic. We have note in the middle where it is fixed, antinodes at the edges. So between two antinodes we have lambda over 2. So we change all given information into SI unit. First harmonic midpoint, so lambda give us lambda equals 4L. For 2L, sorry, 2L here, 2L. Lambda equals 2L, so it is 0.90 meters. We divide speed in metal by, so again we use wave equation for metal. We get frequency in metal, and then as we know frequency, now we have sound in the air with certain frequency, and we should find wavelengths. We know the speed, so again we use wave equation now for air, and we get 18 centimeters, choice C. Question 15. Two charges Q1 and Q2 each equal to 2 nanocoulomb are separated by distance 3 meters in a vacuum. What is the electric force on Q2 and electric field due to Q1 at the position of Q2? First of all, forces are equal and electric fields are equal because of Third Newton's law and definition of field. So we just use electric field force and electric field and electric force. We substitute from the subtopic phi1 for two formulas. We calculate and we get choice A, so 4 times 10 minus 9. So K we take from table. At the beginning of booklet we have data for different constants, so look there. Right, this is done. Two conductors S and T have the BI characteristic graph shown below. When the conductors are placed in circuit below, the reading of the ammeter is 6 amperes. So they are connected in parallel to cell, and ammeter is reading the total current. If we look to the circuit, we see that if voltage, so voltage on these two conductors will be the same. So now what we see, so if voltage is less than 4, the total current will be less than 3 plus 3, less than 6. If voltage on the conductors is more than 5, total current will be more than 3 and 3, more than 6. So it is 6 amperes exactly when voltage is 4 volt. So choice is 4 volt. So here we have text description printed, so if you need you can pause video and see how it is explained here. Question 17. For a real cell in a circuit, the terminal potential difference is at the closest to the EMF when, so not in blue quit, terminal potential difference equals EMF minus current times internal resistance. So internal resistance should be very small to have the internal resistance is much smaller, so closest to have potential difference, terminal potential difference closest to the EMF. So choice A is the best answer. Internal resistance is much smaller than the load resistance. Question 18. Electron enters the space inside a current carrying solenoid. The velocity of electron is parallel to the solenoid axis. The electron is. This is tricky question. Tricky word here is enters the space. Misleading word is current carrying. According to Lorentz law, motion of electron towards coil induce small current in solenoid that will produce magnetic fields that will stop or slow down the electron. So choice A. As it moves parallel to the magnetic field of the solenoid, so magnetic field of solenoid has no effect on electron. But electron itself, because of Lorentz law, is slowing down. Question 19. A child stands on a horizontal rotating platform that is moving at constant angular speed. The centripetal force on the child is provided by some force. The only contact force on child is friction from rotating platform. So we choose B, friction on the child's feet. Question 20. A simple model of an atom has 3 energy levels. The differences between adjacent energy levels are shown. What are the two smallest frequencies in the emission spectrum? So emission spectrum means going down. So the smallest frequency is the smallest energy. So we use energy 6 differences 663 and another 13.3. The only one left is from upper to the bottom, which is much greater. So we calculate frequencies using formula from subtopic 7.1, energy of photon. So we rewrite formula for frequency and we calculate and we get choice C. Now we go to question 20. Question 21. What is the relation between the value of unified atomic mass unit in grams and the value of Avogadro's constant in mole minus 1? So we take values of Avogadro number and unified atomic mass from data booklet, make it grams for mass of uniform atomic mass, and we get so we round values to 1 here, 2 significant figures, and we get about 1, 0.96, so around 1. Choice B. So product is around 1. 22. A hydrogen atom, in hydrogen, the sum of masses of proton and electron is larger than the mass of the atom. Which interaction is mainly responsible for the difference? We use elimination method. So electromagnetic force, no. Gravitational force, no. Strong nuclear force, no, because it is between baryons as proton and neutron, but not with lepton as electron. So what is left? Weak nuclear. So we leave choice C. Which Feynman diagram describes the annihilation of an electron and its antiparticle? So time goes from the left to the right. Antiparticle arrow should be in opposite direction to time. So we choose A, and A works perfect. So we have particle and antiparticle, and then annihilation. So we choose A. Question 24. Burning 1 liter of gasoline produces more energy than burning 1 kilogram of coal, and density of gasoline is smaller than 1 gram centimeter cube. What can be deduced from this information? For gasoline, 1 liter is 10 minus 3 meter cube. Not in book, density is mass times volume. So mass equals density times volume. Mass of 1 liter, density times volume is less than, so gram centimeter cube, less than 1 kilogram. So specific energy density is more for gasoline. So choice B. Here I have probably a mistake. Let's see. So 10 minus 3 here meter cube. 1 gram centimeter cube is 1000 kilogram per meter cube. So that's correct. So only here mistake. So okay, so choice B. Right. Question 25. Which change produced the largest percentage increase in the maximum theoretical power output of a wind turbine? So from subtopic 8.1 we get formula for power. A is area, rho is density of fluid, and B is speed of fluid. So when we double A, power doubles. When we double density, power doubles. When we double radius, because it is, the area occupied by the blades is squared, so when we double radius, the area increase 4 times. Our power increase 4 times. When we increase speed 2 times, the power increase 8 times because it is V cubed. So choice D, the most effect. Question 26. Which is correct for the tangential acceleration of simple pendulum at small amplitudes? So by definition of harmonic oscillation, acceleration is proportional but opposite to direction of displacement. So we choose D by definition of harmonic. So pendulum we know that it is in harmonic oscillations, and we choose D. The diagram 27. The diagram shows the diffraction pattern of light passing through a single slit. So for diffraction we have formula for single slit for minimum. So minimum happens at 1 times 10 minus 2 radians. So minimum equals lambda over b. They ask us lambda over b. So it is 0, 0, 1. So we choose A. Light is incident on the diffraction grating. The wavelength lines 600 and 600.1.5 nanometers are just resolved in the second order spectrum. How many slits of the diffraction grating are eliminated? Subtopic: resolution lambda over delta lambda. M is order, n is number. So it is exactly for this question formula. We substitute lambda and delta lambda. We know order is 2, so we find number of slits eliminated. So it is 200, choice C. On approaching a stationary observer, a train sound is formed and decelerates at a constant rate. At times t, the train passes the observer and continues to decelerate at the same rate, which diagram shows the variation with time of the frequency of the sound measured by the observer. So first it is approaching, so frequency should be higher than reapproaching. Let's check. So everywhere higher than, yeah. But the effect depends on speed. Speed decreases, so effect should be decreasing all the time. So the effect decreases all the time in D. So here effect decreases and effect decreases come closer to horn's frequency. So we choose. Actually, we have also formula. It is Doppler effect, and you can pause video and read the text. So choice D. A particle with charge minus 2.5 10 minus 6 coulomb moves from point X to point P y due to uniform electrostatic field. The diagram shows some equipotential lines of the field. What is correct about the motion of the particles from X to Y and the magnitude of the work done by the field? Motion. So let's see what happens to the energy. So particle goes from X to Y, so potential increases, but particle is negative, so potential energy of particle decreases. It means that kinetic energy increases, so particle accelerates. To find how much work is done or how much energy change, we use formula fields at work subtopic 10.2, multiply charge by potential difference between X and Y. So 700 minus 300, we get minus 1 joule. So work done is 1 joule, and it is accelerated. So choice D. Yes, correct. Which is correct formula for gravitation potential? From subtopic 10.2, we find formula for potential. So we have Gm over R. The same Gm over R we have in formula for the force, gravitational force. So we rewrite this formula to have Gm over R. It is Fr over Rm, and we use base unit for force. It is kilogram meter per second squared. This radius, it is meter kilogram. We simplify, we get choice A. Question 32. A planet has radius r. The escape speed from the surface of the planet is v. At what distance from the surface of the planet is the orbital speed? 0.5 v. Subtopic 10.2, we have escape, expression for escape speed and orbital speed. So escape speed, we use v, as they say. So, and orbital should be 0.5 v. So we have for equation 2, we can substitute expression for v from equation 1. So v from 1 into 2, we get this. We square both sides. and we find that it happens at radius, so it is B. Question 33. A conducting ring encloses an area 2 cm squared and is perpendicular to magnetic field of strength 5 milli-Tesla. The direction of magnetic field is reversed in a time of 4 seconds. What is the average EMF induced? So we change everything in the SI unit. From subtopic we get electromagnetic Faraday's law, EMF. So EMF equals number of turns here 1, change of magnetic flux over time. So because we reverse, we change angle from 0 to 180, so we have 2 times BA. We substitute values and we calculate EMF, so we get 0.50 microvolt. The conservation of which quantity explains Lenz's law? It is about energy, so choice B. 35. Resistor designed for use in a direct current is labeled so much. The resistor is connected in series with alternating current, potential difference 10 volt, peak potential difference. What is the average power dissipated by the resistor in the AC? So peak value is 10 volt. Peak current will be 5 volt because resistance is the same. Subtopic 11.2 power generated and transmission. So it is 1, 2 peak values multiplied. So we get 25 watt. It is choice A. Question 36. A capacitor of capacitance X is connected to power supply V. At time T, the capacitor is connected from supply and discharged through the resistor of resistance R. What is variation with time? So subtopic 11.3, we have formula for capacitor, for how charge is decaying, and time constant. So here we have capacity is X, voltage is V. So it means that when we charge capacitor, it gets charge XY, V, so initial charge. Time constant, we get Rx. So we substitute everything into the formula and we get choice D. Question 37. What is the consequence of an uncertainty principle? So uncertainty principle gives us uncertainty in position of particles. So we choose which line is about position. So about position is line C. Electrons cannot exist within nuclei. Question 38. In photoelectric effect experiment, a beam of light is incident on metallic surface in a vacuum. The graph shows how the current I varies with potential difference when the 3 different beams are incident. Right, so when we illuminate, photon energy is spent to overcome attraction of atoms, so work function, and as a result, electrons has kinetic energy, so they can reach other electrode. But to stop them, we should apply some voltage. So this voltage depends, for the same material, depends only on frequency of the light. So if we look here, we see that lights Y and Z have the same frequency, but they are of different intensity because more electrons are in Y than in Z. So X and Y don't have the same frequency. X and Z have different frequency. X and Z have different intensity but the same frequency. So we choose 2 and 3 is correct. So choice C. As the graph shows the variation with time of the activity of the number of remaining atoms for a sample of radioactive nuclei. So we have activity, so number of decays per second, and we have how many active elements are remained. So we look at both graphs about the information at time 0. Why? Because Decay constant is actually probability of decay. So how many decayed over number of atoms. So how many decayed 0.710 times. How many atoms remained 1.7. So we divide one by another and we get exactly 0.7. You can do the same with one graph, and you can find probability of decay from half-life. But they expect you to use this method, first method. Questions 40. What was the reason of to postulate the existence of neutron? Here you should learn some history of physics. So another particle were involved in energy distribution. This is why we chose D. The energy of emitted beta particles has continuous spectrum. Here we finished. I wish you good luck. Bye.